In this video, we are going to talk about perovskite and ilmenite structure. In case of perovskite structure, there are two types of cations and one type of anion. Now, the general formula for perovskite is AbO3. The larger cations occupy the corners, and the smaller cation occupies the octahedral hole. Not only this, but all the octahedral holes are occupied by smaller cations. And the anions occupy face centers. The face centers are occupied by anions. So these hollow circles are the anions. These corner ones are the cations of larger size. So these 8 are the cations of larger size, and this one is the cation of smaller size. Now look at the example. Perovskite type of structure CaTiO3. Now the coordination number of this larger cation is 12, which occupies the corners, and the smaller cation is 6, which are in octahedral holes, and the coordination number of the anions are 6. So the AbO3 structure, when A has oxidation state 2, B has 6. We can get the structures where A is calcium, strontium, and barium, B is titanium, zirconium, germanium, and tin. Again, AbO3 structure can be formed where the oxidation of A is 3 and the oxidation of B is also 3. In this type of compound, A is generally lanthanum and B can be any one of these aluminium, titanium, chromium, or manganese. So this was all about perovskite structure. Just try to remember the difference of these larger and smaller cations and their difference of positions. Now come to ilmenite. In case of ilmenite, anions forms HCP structure. So hexagonal close backing is formed by the anions, and cation occupies octahedral holes. 2/3 octahedral holes are filled and 1/3 octahedral holes are vacant. So in case of ilmenite, the anions form HCP structure and the cation occupies 2/3 octahedral holes. It has also the formula AbO3. If A and B are same, that means if it becomes A2O3, that will become the formula of corundum. So it is similar to the structure of corundum, where the coordination ratio is 6:4. In case of corundum, the cation has a coordination number 6 and anions have coordination number 4. So Al2O3, F2O3, Cr2O3, V2O3, these are the examples of corundum type structure. In case of ilmenite, there are two types of cations. Look at the compound FeTiO3. Here also the coordination number of the cations are 6 and the anions are 4. In case of the oxidation state of A is 2 and B is 4, we can get these structures where A is Fe, Cd, Mg, and Co. That means iron, cadmium, magnesium, and cobalt. And B is titanium. Again, if the oxidation state of A is 1, then oxidation state of the B will be 5. And the structure can be got when A is lithium and B is niobium. So this is all about ilmenite structure.